Bismillahirrahmanirrahim. Students, in today's lecture you will be able to learn electric flux and Gauss's law. So first of all we will discuss that what is electric flux. Electric flux is the number of field line passing through a certain area is known as electric flux. Means that the electric field lines, we have already discussed that what are field lines in our previous topic. So that field lines, when they are passing through certain area, okay, any area that we placed in front of the field lines, so that the number of field lines, for example, if we have certain area and in that area two lines are passing, so we will say that okay, the flux is 2. Okay, two lines are passing, that if 3 passing, 4, 5, like this. So the number of field lines passing through certain area is known as electric flux, or its second definition is that the dot product of electric field intensity, you know that it is represented by E, and vector area is A. So the dot product of E and A is called electric flux. So these two are the definitions of electric flux. Now it is a scalar quantity and it is denoted by a Greek letter phi. Okay, if you look at in this diagram, so this blue one, its shape is just like a rectangle shape. So this is a certain area and the black lines are the electric field lines. Now these lines are passing in this area. Okay, so the number of lines passing in this area is the electric flux. Okay, and it is denoted by phi, and it is equal to E dot A. E dot A is equals to EA cos theta. Cos theta is that angle which this electric field is making with this area. ठीक है, इस ब्लू वाले बॉक्स में आप देख लें, ये एरिया जो है यूनिट वेक्टर, ये इसकी डायरेक्शन है. ये मैंने आपको पहले भी क्लास में समझाया था कि हर एक जो है हर एक चीज़ जो होती है उसकी डायरेक्शन जो है उसके परपेंडिकुलर होती है. ठीक है, तो इस एरिया की भी डायरेक्शन इसकी परपेंडिकुलर है नॉर्मल जब हम उसका ड्रॉ करते हैं. सो दैट ए and this E is making angle theta in this case when this area is not straight, not parallel, but it is tilt. In the second diagram it is also clear that in the when the area is placed straight, okay, so when the area is parallel, so many lines are passing, and in the previous one, the area when it is tilt, so less lines are passing. Now mathematically phi is equals to E dot A and EA is equals to EA cos theta. Further, now we will discuss its cases, that when the flux is maximum, when the flux will be minimum, okay, or zero. So when more lines are passing through a certain area, so flux will be maximum. When less lines are passing through area, so flux will be minimum. But how and when the more line will pass, and how and when the less lines will pass? So the answer is here, that if the vector area A is taken parallel to the field line, means कि अगर ये एरिया जो है, एरिया यूनिट वेक्टर जो है, यानी उसका नॉर्मल जो होता है एरिया का, वो और ई जो है इन दोनों के बीच में एंगल ज़ीरो आ रहा हो. ठीक है, सो इट मीन्स मैक्सिमम लाइन्स आर पासिंग एंड एंगल इज़ ज़ीरो. And when we put it in this equation, phi is equals to E dot A, EA cos 0, so it will comes EA. ये phi E लिखा है, ये E by mistake लिखा है. ठीक है, इसे आप इरेज कर लें. Thus the electric flux through an area element will be maximum when E is parallel to A. In this diagram I will show you, if you look at the first one, in this the area is making some angle phi. Okay, so neither maximum nor minimum lines will pass, but some between these maximum and minimum some lines will pass. Now in the second diagram, if you look at here, so the area is perpendicular to this field lines, but एरिया तो परपेंडिकुलर है, लेकिन उसका जो यूनिट वेक्टर है, उसकी जो डायरेक्शन है ए, दैट इज़ पैरेलल टू फील्ड लाइंस. ओके, तो ये दोनों क्या बना रहे हैं, एंगल फाई बना रहे हैं. सो इन दिस केस द मैक्सिमम लाइंस विल पास. In the third diagram, if you look at here, so the unit vector area and the field lines are making angle 90. So in this case, when we put in equation, so EA cos 90 is equals to 0. So in third one, the minimum flux or zero flux will be there. Its mathematical equation is in this slide. Cos 90 is equals to 0. Now electric flux through closed surface. In this we will just discuss that what will be the electric flux through any closed surface. Okay, so the flux in any closed surface is the same E dot delta A, or if there is a closed surface, so we will add that areas into small patches, and then we will find the electric field at point 1, point 2, point 3, and finally we will add all these electric field and will write it in the form of summation. In the second equation, it is phi or flux is equals to summation E dot delta A, means at point 1, point 2, point 3 up to point n, we will add all these and we will get the total flux of through any closed surface. Okay, if we look at these 3 points, the electric flux is positive if net number of electric field lines are leaving the surface. That is, there is a source of field lines in the closed surface. The flux lines, the electric flux value is positive if the field lines are the total end result, the field lines are leaving the surface. Means some lines are coming, some are leaving, but the net flux is leaving the surface. And the flux will be negative if the net field lines is entering the surface. Okay, and if there is an equal number of entrance and outgoing, so there will be zero flux. Now we will discuss Gauss's law. Gauss's law, as we know that flux is equals to E dot A, Gauss's gives us an equation in which we can easily find out the flux. Okay, what is that equation? It states that the total electric flux through any closed surface is equals to 1 by epsilon naught times the total charge enclosed in it. यानी गासिस ने हमें ये बताया कि फ्लक्स जो है वो आपके साथ इक्वल है 1 बाई एप्सिलॉन नॉट टाइम टोटल चार्ज इनक्लोज्ड इन सरफेस. अगर आपके पास कोई भी सरफेस है, उसके अंदर जितना उस सरफेस के अंदर इंटरनल अंदर उसके जितने भी चार्ज है, उसे अगर हम डिवाइड कर दें एप्सिलॉन नॉट पे, एप्सिलॉन नॉट यू नो दैट परमिटिविटी ऑफ फ्री स्पेस, उसकी वैल्यू भी फिक्स है, आपको पता है. ठीक है, कूलम्स लॉ में हमने पढ़ा है. तो अगर आपको सिर्फ टोटल नंबर ऑफ चार्ज पता चल जाए, सो यू कैन ईजीली फाइंड आउट द electric flux. So this is a very easy way of finding electric flux of any surface. Now we will discuss its proof, that how this equation came. Okay, so for this we will consider a sphere. We will consider closed surface in the form of sphere, and its radius is r and charge q is placed in its center. Okay, so what we will do, we will divide these surface into small areas 1, 2, 3, 4 up to n, and at each point the electric field will be E1, E2, E3 up to En. ठीक है, ये सारा. फिर क्या होगा, at every point we will find the flux and then in the end we will add it. Now look at flux 1, E1 dot delta A1. ठीक है, 1 को 1 से हम एरिया 1 और इलेक्ट्रिक फील्ड 1 से हम फ्लक्स 1 फाइंड कर लेंगे. देन फ्लक्स 2, फ्लक्स 3. ठीक है, दोनों के बीच में एंगल 0 बन रहा है, सारों के बीच में एंगल 0 बनेगा, बिकॉज इस डायग्राम में हम उसे बड़े स्मॉल पैचेस हम ले लेते हैं. ठीक है, then we will add all these flux and we will get the total flux, that is summation E delta A. ठीक है, अब अगर आपको याद हो तो हमने इलेक्ट्रिक फील्ड ड्यू टू पॉइंट चार्ज पढ़ा था कि वो बराबर था E इज इक्वल्स टू 1 बाई 4 पाई एप्सिलॉन नॉट Q बाई आर स्क्वेयर. वो वैल्यू हम यहाँ पर पुट कर लेंगे. ठीक है, और डेल्टा ए की बजाय हम स्फीयर का, आपको पता है स्फीयर का एरिया क्या होता है, 4 पाई आर स्क्वेयर, तो डेल्टा ए की जगह हम 4 पाई आर स्क्वेयर पुट कर लेंगे. इसमें 4 पाई और आर स्क्वेयर कैंसिल हो जाएंगे, तो क्या रह जाएगा, Q बाई एप्सिलॉन नॉट. सो इट इज़ प्रूफ दैट फ्लक्स इज इक्वल्स टू Q बाई एप्सिलॉन नॉट. ओके, Now if we want to find the total flux, if we want to find the flux of a shape in which we want to divide it into patches, okay, so what we will do, flux 1, flux 2, flux 3 up to flux n. Flux 1 क्या होगा, q1 by epsilon naught प्लस q2 बाई एप्सिलॉन नॉट प्लस q3 बाई एप्सिलॉन नॉट, सारों में कॉमन हम ले लेंगे, सारों के चार्जेस हम ऐड करेंगे और समीशन ऑफ द चार्ज से हम टोटल चार्ज फाइंड आउट करके हम उसका फ्लक्स फाइंड कर सकते हैं, ठीक है, किसी भी क्लोज सरफेस का जिधर चार्जेस बहुत ज़्यादा हों, एक चार्ज ना हो, डिफरेंट हो, ठीक है. सो दिस इज़ द गासेस लॉ एंड now we will come to our assignment. Your assignment is that you have to practice a lot on Gauss's law, okay, and read electric flux through closed surface topic carefully and revise your all topics, okay. And if you have any problem, any question, ask me and give me your feedback, okay. Thank you.